Okay, hello students. Here I'm working on this is lesson number 5 and unit 3 rational exponents. And the main idea is that everyone need to know that b raised to m over n, because last time we have seen if it is 1 over n, then it is nth root of b. So the only extra here is instead of 1 you have that m, right? Now this m, the nth root that you have is, I can write nth root of b, and I can also write nth root of root. But and the black one, let me use the black as the b. Okay, the b, and the m can be written as either it goes outside or inside. That's all it means. So just an example now, straight away will go, or this could be also even for the for any m and n integers. Of course, n cannot be 0. Let's see, the first problem is, question is asked, can we write this? So the first one is square root of 5 raised to 9. What this means is this 2. So in the v that you see in the radical sign, that is 2, and this is 5 raised to 9. And when you compare with the radical form, what is m and n, and you can see the red one is the 9 is the raised to the power 5, and put black is the 2. So you have to write the blue 5, this equals 5 raised to the, and then there is a rational form, the exponent is the rational, so the 9 goes up, which is the m, and the black one goes 2, and you're done. That's all they're asking. If you see the second question, this one is 1 over cube root of 12. Now, first of all, we'll forget this part. There's a numerator and the denominator. We'll work out only the denominator. That means cube root of 12. What does this mean? It is cube root of 12 raised to 1. It means it is, by that formula, we can write 12 raised to 1 over 3. So this becomes 12 raised to 1 over 3. Using the same formula, and then we have, if we have a raised to minus p, and we have seen that this is a raised to p, or if it is 1 over a raised to minus p, it is same as a raised to p. This is the formula to be used. So now the exponential form is at the bottom with the plus sign here, with the plus sign. So we can raise it to up. That means you can write it with, but it changes to minus. And why do we have to write this? Is because the question was, can you write in the form of a raised to the power b? And this is a raised to the power b. So a is 12 and b is minus 1/3. And that's how you do the work, and you're done. I hope this takes. Before I complete the problem number 2, let me check one more an example. Suppose you have minus 7 raised to 2/3. So what does this basically means? This is basically means you can change this minus, right? Remember, if it is a raised to minus p, write it as a raised to plus p. That's all you're supposed to write. But last class we have seen, if this is negative, we can always write this, which is 7 raised to minus 1 times 2 raised to 3. You can always write this as 7 times 2 raised to 3 times minus 1, and you can use the power of power and say this is 2 raised to 3 minus 1, and this is cube root of 7 square raised to minus 1. See, and then you can write this as, because of this minus 1, you know that a raised to minus 1 is 1 over a. So this becomes 1 over cube root of 7 square. Of course, you know the answer. 1 over cube root of 7 square is 7 times 7 is 49, and you're done. So this is how you're supposed to do. And then I want to walk through one more. Suppose there is a fourth root of 11 raised to 5. So what this means is you want to write in the exponential form, and you can see this is of the form n square root of b raised to m, which is b raised to m over n. All you do is the outside 4, you just have to divide here. It means this 11, the b is like 11, this is the b, this is 11, so 11 raised to, and the 4 goes down, and the 5, the blue one, goes up, and you're done. That's all it is. Okay, now look at this is question number 2, and they're asking the first one, 8 raised to 1/3. So what is this 8 raised to 1/3 is? Basically it is, you can, there is another way to write it, is 2 raised to 3 raised to 1/3. And this becomes 2 raised to 3 times 1/3, and that is 2 raised to 1. You know the answer. But the right way to write in the radical form is you write cube raised cube of 8. So what number multiply itself 3 times to give you 2? So the answer is 2. So this goes right here. Now, what's the difference between A and B? The only difference in A is there's a minus, so all you do is drop it down. But then we all already know this answer is 2, right? So it becomes 1.5. So where is 1.5? So this goes right here. What is 8 raised to minus? There's a minus 1, so it becomes 1 over 8. So that means where is 1 over 8? It comes here. What is this? This is the square root of 16 because there's 1 over 2. Remember, if you have b raised to 1 over n, it is nth root of b. And square root of 16, what multiply itself 2 times to get 16, and the only number is 4. So this goes right here. The only difference from here to here is this is you have to drop it down and say, hey, 16 with the positive half. But we already know what is 16 raised to half here, which is 4, so 1 over 4. And the final it is 16 raised to 0 is always 1. Anything b raised to 0 is 1. So naturally this will be always 1, and you're done. So hope that helps. In question number 4, you're supposed to complete the table using the powers of 20. So you have to use power 27 here and also 27. That's what it says. But for the top row, but for the second one, you have to use the radical or rational, maybe raised to something over something. So that means I have to write something over top and something raised to something over something. Let me write whatever. The first one is already an example, which is 27 raised to 1 is 27. The second one, so the bottom is square root of 27. So by the definition of square root, or we can write always this as 27 raised to half because there's a 2 here. So that means this is how it is. And the next one you have to write in the cube root form. So this 3, which is like a m over n, so the n is this one, and 27 raised to 1, so you're done. That is cube root of 27. So this is cube root of 27. Now there's a 1, it means it is everything raised to 0, anything raised to 0, so you just put 27 raised to 0 is there. And the next one is 27 raised to half. So this is 1 over 27 raised to half, because when you write b, a raised to minus p, you write it 1 over a raised to plus p. So that's what you do here. But then you need to write in the radical form, so you write it as square root of 27 So this answer which is here should be 1 over, here the answer is already given 1/3. So if it is 1/3, what should be this? That means, let me write it nicely. So this is 1/3, right? So that means it is raised to 1 over cube root. Basically, it means it is cube root of 27, because we need to write 27 here, right? So the question is to put 27. So 1/3 is same as cube root of 27, and we can write it as, so which can be written as 27 raised to 1 over 3. Remember the trick is, and then you're going to use this formula when minus changes to plus, or if there's a minus here, it becomes a plus here. So now there's a plus here, so you can raise it up and raise it. And that's what you're supposed to write right here. 27 raised to minus 1/3, and you're done. So what are the solutions of this? So there are two ways. See, the right side is -2, so I can write by x minus 1 and x plus 2, and I can also write x minus 1 and x plus 2. And you need to get -2, right? So it could be -1, 2, or it could be +1, 2. It could be 2 and -1, or it could be -2 and plus. So a lot of options there, but I would like to want you to use and directly use FOIL method or the box method for distributive property. Is what is the left side is. So if you do this, x times x is x squared, and this is 2x, and this is minus x, and this is -2, and you can see you get x squared plus x minus 2, and the right side is -2. Add to both sides, and you get x squared plus x, and both will be 0 equals 0. That means you undo distributive property and you get x. And then you say, okay, either x equals 0 or x plus 1 is 0. The only way to get this x plus 1 to be 0 is -1. So your two answers are -1 and 0. So this is how you do it. The question arises, why? Why is this is same as this? So the reason is, if you see this, uh, this is cube.